Yeah. Um, Now I'll share the learnings. Uh, learnings. Hmm. So this we have gone through like sorting. Okay, sorting. In sorting, there are three selections: bubble and merge, sort. Okay. Now I would go with each and everything. I'll just go with the definition as well. Selection sort. So basically, like, uh, let's say I have 13, 17, 14, 30, 78, 20, 35, let's say, right? And this is like the sorting happens between two numbers, each two numbers. Like, you know, if we take 13 and 17, the small number is the 13, like it'll be staying at its own place. And then we have 17 and 14, in which this 14 is lesser than 17, right? So the pattern becomes like this way, and then followed by like the next two numbers like 17 and 78, it is correct only. And if you consider the next two numbers like 78, 35, 35 is smaller than 78, so both of them gets swapped. So 35 followed by 78. So this is how selection sort happens. uh, Basically, like, let's check the definition part. mm, yeah, the space complexity, like time complexity. Hmm. Yeah. So the definition, like the code would be in this way, like starting from 0 to n minus 1, because in that n numbers, like we are starting from 0, not from 1, so it will be like n minus 1 will be the last term in the series. And we need to check the smallest numbers between every two numbers, the ith number and the n minus 1 number, and we need to swap accordingly, and we need to iterate the process. So yeah, I'll just mention that as well. uh, hmm. For I from 0 to n minus 1. mm, okay, find the smallest numbers uh, between I and n minus 1, swap the two numbers. hmm. Sorry. That's all. Numbers, give it bracket. Then we have uh, bubble sort. So bubble sort, what is time and space complexity? Okay, the time required to run the program and the space required. Okay, O1. Okay. Now let's talk about bubble sort.
Or a finger, if you will, and point at bubble sort. Technically, +1. Person in my right hand is
So in this, like the last, the number will be sorted first. In selection sort, the first number will be sorted like the smallest number, and in bubble sort, the largest number will be sorted first. So that's why they have mentioned n-2, not as n-1 in the previous case. And we need to repeat it n times only, because automatically the last term will get sorted. Yeah. You can see initial this number, both of them get sorted. Yeah, the larger number gets swapped. Yeah, probably this is the way. We can copy it and we can just keep it this way. Yeah. This will be the code part. Repeat n times for I from 0 to n-2 if the numbers and the numbers are of order swap. Yeah. And then we have recursion.
highlighted, or generally
Yeah.
recursive lines that I've highlighted are generally called recursive cases, whereby you don't get an answer yet. You have to do more work by generally shrinking the size of the problem and doing the same logic again. So a recursive algorithm or recursive function is one that calls itself, that uses itself, but hopefully on a smaller and smaller size problem. All right, so for
Just like the search. No. Like, else if
Same
for recursion. So this is another recursion example that has been done. So basically, like in this, I'll just run it. Uh, I'll just run the code and say you. So so it will be asking the user to give the input for the height. Let's say I keep it 5. So I see that there are 5 rows with decreasing number of hashes representing a pyramid. So basically, like, this is a recursion because it will be calling itself until this gets stopped. So mostly I will check the code. So CS50 standard IO libraries, and then we keep this int main void. So we int height, the height will be integer, and the get int will be from the CS50 library, just so that the user can give input for the height. So, and then draw is used for visual representation actually, and then we need to, like, the n will be the height, it's like the number of rows, height of the pyramid, and I will be the number of ashes, hash tags, basically the hash tags which represent the bricks in the pyramid. So if n is less than or equal to 0, which means the height can't be 0 or less than 0, that means the pyramid won't be existed, so it will be calling return. So, and followed by n minus 1, obviously we are starting from 0, so it will be like 0 to 4. And this is the code for printing the hashtags which represent the bricks in the pyramid. So we are making I, which is number of bricks, as integer and equal to 0, the initial value, and it will be less than the height. N will be n is height. High plus plus is like the iteration process, and we need to print hashtag, and eventually it will print it in the next line. Yeah, this is how it works. I will just copy this as well. Okay, now followed by merge sort. So I think we'll be showing one image, we can get an idea. Yeah, this is exactly how it works. So there are 8 digits, right? So we'll be dividing it into half, 4 each, and in that 4 also we are dividing it into 2 each, and those 2 are divided again into 1. It is a similar case with the right part of it. So in the 6 3 we'll be sorting now, like the 3 comes first followed by 6, and in this 4 1 comes first followed by 4, and now we are having 3 and 6 here and 1 and 4. So eventually the 1 comes first followed by 3 and then 4 and then 6, so that the first half will be sorted saying 1 3 4 6. Similarly this one goes also that way, and then the cycle repeats again for this as well. The 5 comes, the number that is here comes first followed by the corresponding number. Let's check.
I've said completely merge. Sort a list of size.
We can take this as an example. This explains how it works. So yeah, selection sort comes from first, bubble sort comes from last, and the merge sort comes like they'll divide it into half and half and then merge. So basically merge sort is more time efficient over the next, and next selection sort. Yeah. Time selection sort greater than merge sort greater than, basically time taking would be less, so it will be less, the bubble sort will take more time. You can also have an image of this
On this final.
That's it for this video.